Okay, we have a little kid running a lemonade stand, selling small and large beverages, and each small beverage sells for $2, and each large beverage sells for $5. Small beverages require 4 lemons and 6 tablespoons of sugar. Large beverages require 5 lemons and 10 tablespoons of sugar. She has 100 lemons and 180 tablespoons of sugar. We want to know how much of each beverage she sells to maximize her earnings. So this is a maximization problem, a standard maximization problem where we've got two constraints. We have limitations on the amount of lemons that we have available, and we have limitations on the amount of sugar that we're trying to solve. And the things that we're trying to find is the number of small beverages and the number of large beverages. Beverages that we're trying to find. Those are the unknowns. How many smalls and how many larges can we make and stay with our 100 lemons and 180 tablespoons of sugar? And we're trying to maximize the revenue. And our revenue is $2 for a small and $5 for a large. So for every small that we sell, if we sold 10, we'd bring 2 times 10, we'd bring in $20. If we, and 5 times y will tell you how much money you make from the large ones, and add them together, you get your total revenue. All right, so we've got our objective function. We want to maximize our revenue function, and our constraints. We've mentioned already that we have 100 lemons, and so we can use up to 100 lemons, and we know that each small beverage uses up 4 lemons. So if I made X of them, I'd use 4X lemons. If I made 10 small lemonades, I'd use 40 lemons. If I made 5, I'd use 20 lemons. 4 times however many small I use is going to make 4 times X would be how many lemons I use making small ones. And large require 5 lemons each, so 5y is less than or equal to 100. And our other constraint that we have is the 180 tablespoons of sugar, and I use 6 in every small one and 10 in every large one. And so 4x plus 5y has to be less than or equal to 100 lemons, and 10x plus 10y is less than 180 tablespoons of sugar. And of course we also have the standard constraints that x has to be greater than or equal to 0 and y has to be greater than or equal to 0, because we can't make a negative number of glasses. And we're going to solve this question by graphing. And so I want to graph my 2 linear inequalities and find the corner points. And I know that I'm looking at in the first quadrant here because I've got that x is greater than or equal to 0 and y is greater than or equal to 0. So I want to first start off with the 4x plus 5y equals 100. And in this, if we let x equal 0, our equation just turns into 5y equals 100 or y equals 20. So my that first equation is going to cross the y-axis at 20, and it's going to cross the x-axis. If y is equal to 0, I'll get 4x equals 100 or x equals 25. So let's put 25 about there, roughly speaking. And then I also need to graph my sugar equation, 6x plus 10y equals 180. And we see that if x is equal to 0, we'd get that 10y is equal to 180, so y is equal to 18. Oh, whoops, I should have drawn in that first line. My first line connects those 2 points. There. And then I'm going to cross at 18 on the y-axis if x is equal to 0 on my sugar equation. And if y is equal to 0, x would be 30. So we're going to be 30 here somewhere past 25. And so my sugar equation would be this one. And both of these are, the solution side for each of these is the 0, 0 side. If x is 0 and y is 0, this will be a true statement. The 4x plus 5y will be less than or equal to 100. You'll have 0 is less than 100, which is true. And so I'm looking at the 0, 0 side of my lemon equation. And if you check with the sugar equation as well, 0, 0 is also a solution. So I want the 0, 0 side of the sugar equation. And so my feasible region is this area in here. And I want to identify the corner points. Corner points are 0, 0. It looks like 0, 18. And 25, 0 is another one of my corner points. And then there's one other corner point right here where the two lines intersect. And I need to come up with a way of finding where those two lines intersect. Let me look at it. I think I can do elimination fairly easily. If I multiply the top equation by -2, it'll give me a negative 10y in there. And when I add those together, the 10y's will cancel out, and so I'll just have an equation of minus 2x equals minus 20, and so x equals 10. So the x coordinate for this point here is 10, and then I can take that 10 and plug it into either equation to find the y coordinate. Let's do the 4x plus 5y equals 100. 4 times 10 plus 5y equals 100 gives me 40 plus 5y equals 100. 5y equals 60, or y equals 12. So this should be 10, 12 would be my corner point there. And if we were really careful with our graphing, we maybe could have read that off, but we weren't all that careful with our graphing. So I'm not 100% sure that that's about, well, maybe it is. If that's 18, if that's a difference, yeah, that might be 12 there. Well, that's only 2 smaller. Yeah, I didn't do a very good job graphing it, but I got the general idea and I can identify my 4 corner points that I'm looking at. And so what I want to do then is take those 4 corner points and try them in my objective function. R equals 2x plus 5y. If x is 0 and y is 0, my revenue will be 0. I won't make any money if I don't make any glasses of lemonade. If I look at 0, 18, if I plug in 0 for x and 18 for y, 2 times 0 is 0, 5 times 18 is 90. So I'll have $90 in revenue at that particular point. 25, 0, if I plug in 25 for x and 0 for y, 2 times 25 gives me 50. 0 times y, or 5 times 0 is 0. So I get $50 in revenue at the point 25, 0. And then finally check 10, 12. Plug in 10 for x would be 20, plus 60 gives us 80 in there at that particular point. We're trying to maximize our revenue, so our biggest value for r is right here. When x is 0, y is 18, I'll have my maximum revenue of $90. So 0 smalls, I want 0 small, and 90 or 18 larges will give me $90 in revenue, will be our maximum. And that would be our solution.